Hello? Yeah, it's plugged. Okay, great. Hello, everyone. Uh, I'm Ernesto. I'm a senior software engineer at YouGov. And, well, basically, 1 year ago, I started working on a project where we have to ensure health and quality of an application to being able to meet some customer needs. So basically, we needed to understand the internal behavior of an application to understand if it was performing as we expected. And so I started approaching the observability concept and the world of the software telemetry. So have you ever heard about software observability or telemetry data? Yeah, I think so. Okay, so let me first introduce the meaning of observability. Observability comes from the study of the control theory, and what Wikipedia states is basically that observability is a measure of how well internal states of a system can be inferred just reading at the output. But basically, in my opinion, or maybe your opinion is the same, this is what monitoring is. Because we don't have any visibility on what's happening inside the application, okay? So if we have only the perspective of the outputs, and let's say how many errors occurs, how many requests occurs, we can understand none of the internals. So I guess this definition of observability cannot be applied in the tech world. But what observability means in tech, in my opinion, is to look to see inside the system. So, and therefore follow the inputs through the system to their respective outputs. Why we need observability in a software? Well, as a developer or in general as a IT operator, we are in some ways responsible for the performance of health and the application that we build. So most of the time, taking tracks of the performance indicator is critical, and especially in distributed system, I will say that we have to be sure that what we have is performing as designed. So imagine we wanna keep track of several information, and so when we talk about observability, we are going towards three particular aspects that are logs, metrics, and traces. These altogether are called telemetry data. That is to say, the information that we will use to determine whether the application is healthy and is performing as designed. So, a next thing that we have in this field that besides time, oh, it's gone. Okay. Besides time, there is something that unify these three aspects. And I would say that everything is based on events. So if we consider logging is pretty straightforward. It's basically records events. When something happens in the log system, we record them, and that's it. On the other hand, we want to gather other information coming from logs, and maybe we want to do measurement of our logging information. We can gather them and then collect metrics. And from metrics, we can then measure other things like requests per second and aggregate other kind of data. Tracing as well is based on event, but the key difference here is that we have got the casual ordering. And so you'd be able to tell the impact of one request, like did it spawn in other 5 requests? Did a failure of that call on an upstream request that failed, or I don't know. At the end, we can look at aggregates data and taking into account particular IP or particular context of each traces that we have. So the 3 of them, logs, metric, and tracing, are all based on events, but they have different things to add them when we try to understand the systems. Now, let's find another way to relate these 3 concepts. I will say that logs, metrics, and trace can collect response time, right? So log, the single event, we have the response time. Like in this case, we have a log entry where this request, at the end of the entry log, we have the response time. If we don't have that, we can infer that just looking at the previous and the next entry log in the system. But in this case, we have this 493 milliseconds request. It was a long request that we collect in the log. But then we use the metrics to understand if this 493 milliseconds was enough or it was slow. And maybe if we wanted to use this request to compare with the other requests, we can just check the time, at what time that request happened, and then we can say, okay, maybe it was low but not critical at that time that it happened at 10:27 a.m. So metrics can be very helpful to set alerts according to some thresholds. Then we can create dashboards to understand the trends of the performance within our systems. Now traces also has response time, but in this case, we can tell the impact of something within the request. So if this was a, let's say, 400, almost 500 milliseconds request, like the get with the blue highlight in the picture here, we can see through the trace that perhaps something happened. Maybe there was an error at some point, maybe in the ticket service, or probably some request got, I don't know, some latency error, and then we have the information about the timing, we have a context, and within this case, so having all the response laid out, we can understand the solution, or some way we can understand the solution to adopt, and the easy fix to write, to fix down. So consideration here is that logs are easy to grab. They can basically, we can read it manually and understand something about our monolith application. Metrics can help us to understand the trends of the performance within our application. Traces, on the other hand, can identify cause across services. And for this reason, I would like to focus the attention on the concept of distributed tracing. Okay, distributed tracing allows your system to receive a request and track that work as it interacts with various functions, methods, or other services within your distributed system that comprise your application. A trace shows you how a request propagates from one microservice to the next in a distributed architecture. So the basic building blocks here of a request, they're called spans. And each span corresponds to a distinct invocation of an operation that has been executed as part of the request. Each span contains 4 pieces of information plus, I would say, plus this additional context that we as a developer, we can always inject when we trace something in our software. So we have the span ID, the parent span ID, the start time and the end time. And with the spans, and with spans data actually, we can reconstruct the execution of the entire application. Let's do an example here. So we have an e-commerce store, and the first request is to call the store page. We have the span ID 1. We don't have any parent ID because this is the first request. Starts at 8:30 and at 8:50. So it was a 20 minutes duration request. But during this request, this store called the catalog microservice with a request with the span ID 2. It depends that comes from the store microservice. So it was parent ID 1, 8-minute duration, right? But imagine that the catalog want to check for the stocks availability of 3 products here. So we have 3 requests that comes from the catalog to the stock service. And so we have the ID 3, 4, and 5 here with the parent ID 2. And again, maybe there was coming as well from the store service another call to the authentication or authorization service over there. So basically, we now have the entire request laid out. And if we have a problem, like, I don't know, increase of latency, some errors, or something that is going on in our system, it is much more easier to find where that is. So we don't have to infer anything from the metrics that we already gathered. With distributed tracing, we observe requests, right? So as they move from one service to another, and it's superbly practical for a number of reasons, such as understanding your service connection and diagnosing latency issues, among many other benefits. However, if the majority of all your requests are successful and finish without unacceptable latency or errors, do we really need all these trace data? I mean, we are collecting data and we are putting a lot of information for successfully requests. We don't need that. We only need something that can monitor our performance of the application, right? So what we can do, trying to avoid to overload systems with our data, is to use sampling. So we can just sampling the data. And the idea behind sampling is to control the spans to send your observability backend results in resulting in lower ingest costs. I would like to mention 2 techniques that observability has. I mean, these are the 2 the most used in nowadays. The ad sampling is a sampling technique used to make the sampling decision as early as possible. Let's say that we decide to sample or drop a span or a trace is not made by inspecting the trace as a whole. For example, the most common form of heading sampling is the deterministic sampling. And in this case, a sampling decision is made based on the trace ID and a desired percentage of the trace that we want to sample. So, for example, to ensure that the whole trace are sampled with no missing spans at a consistent rate, let's say 5% of the whole traces. Tail samplings tail sampling on the other hand is where the decision to sample a trace or a span takes place considering all or most of the spans within the trace. For example, tail sampling, we can use tail sampling to sample always the traces that contain an error, or sampling traces based on the overall latency. So as you can imagine, tail samplings allows for much higher sophistication, and for larger system, I will say that we want to sample telemetry. It's almost always necessary to use the tail sampling. On the other end, on smaller application, the ad sampling is always the best case to adopt. So how can we then implant observability in our systems? We have tons of possibilities. The open source world has OpenTelemetry that is a framework designed to provide a unified, cohesive, and open source approach to the collection and filtering of data. It has a lot of unique API, SDK for a lot of programming languages and some amazing exporter that we can use to analyze our telemetry data. It was created by the merge of OpenTracing, that is the standard for generating traces, and OpenCensus, that's the standard for generating metrics data. Some statistics on the internet that I just bought lately reveals that companies uses several tools for getting logs, metrics, and traces. So the stats says that from 5 to 10 tools have been used in the companies to collect telemetry data. Well, we can reduce these tools using basically only the OpenTelemetry ecosystem, because it has a standard API, a single standard API, a lot of specific SDKs, and some helpers for the most famous web framework. In Python, I would say Django and Flask, even FastAPI and other kind of frameworks. It also has some recent implementation that is called the auto-instrumentation library, that it basically gives you the possibility to instrument your traces with zero code. It's basically just collecting the data with a command. OpenTelemetry provides organization with an open standard, offering a single set of libraries for the code bases and a unified agent called a collector to receive metrics, logs, and traces. So we have actually two ways to send trace data to our systems. The first one is to manually send the traces to our backend just using the SDK and the API of OpenTelemetry. On the other hand, we can use the collector. So the collector helps us. Let's say, imagine the collector as a service that runs, and we can send data, push or pull data from the collector to our service or vice versa using the gRPC protocol. In general, using a collector alongside the services is the recommended part, but if you want to start using telemetry data, if you want to start collecting telemetry data using the manual approach, maybe it's the best benefit you can try to for, let's say, quick results, quick inspection of the data that you're getting. And I hope that the demo works, and I will show you how it works. Demo live. Finger crossed, yes. Well, the OpenTelemetry collector consists of three main components: the receivers, the processors, and the exporters. As you can imagine, receivers are used to get the data into the collector, and nowadays, OpenTelemetry, I guess, it supports kind of 40 different type of receivers with the OpenTelemetry protocol standards, but you can send also other kind of formats like Jaeger, Prometheus, or other formats. The processors receives the collected data, and it basically crunch the data. And when I say crunch, I mean we can do data scrubbing, we can do normalization, and more importantly, we can filter private and sensible data from within the traces and the spans. Because when we use then the data in the exporters, where we can see what's going on within the traces. We do not have any user information. We can remove IP addresses and stuff that are basically private for the customer, and we cannot use to infer something. Of course, given the SDK of OpenTelemetry, you can write your own module within the processor to manage the data. So it's always extensible, always customizable in every part of the pipeline. So you can write your own receiver, you can write a module for your processor, and of course you can use which exporter do you prefer, open source or, I don't know, enterprise vendors like Sentry or Honeycomb, stuff like that. Okay, so let's see some really easy code here. Here we are instrumenting a Flask endpoint, that is the roll the dice. The easy thing to do here, let me do that. Basically here, with this context manager, we are saying, okay, what is underneath the context manager? Start the trace, the span called the role as a role span, and everything within the trace will be collected as a span in our tracing system. It's pretty easy. Just import our OpenTelemetry trace and instrument it, instantiating the tracer and then using the tracer within a context manager. As well as you can use, instead of the context manager, if you want to trace the whole function there, the role function, you can use a decorator as well, because OpenTelemetry gives you the possibility to use the decorator rather than the context manager. Now we have the demo, and I hope it works. So let's see here. All right, okay. What I've done here is basically I follow the demo example here. Just I build this Docker environment that gives you all the stuff for telemetry data. So we have a web store here. We go shopping. We buy a binocular. We add it to the cart. And we place the order. Right, so what we have done here is a checkout operation, right? So we have a checkout service in the service here. I'm using Jaeger as exporter. This is Jaeger web interface, an open source web application that gives you the possibility to query within the traces. So I found the trace. This is my last trace, and of course it won't work. Yeah. Or let's see if something comes in the front end. Yay. Well, let's see the other thing here. This is the example that you saw on. Okay, so if I go here and okay, the roll dice, and as you can see, when I run the roll dice, I run the OpenTelemetry instrument with the example that I just showed you in the slides. And this is collecting the spans as a JSON format And this format can be used to send it to Jaeger, for example, and check the telemetry stuff there. So if I do another turn here, whatever, I see here other requests coming through the system. Let's see if I can run again the OpenTelemetry. I have 50 seconds. So let's see if it's... Let's try again. Yay, it worked. So here we have all the trays laid out. Starting from the front end, we are seeing all the services here that have been called during the request. And then if we are interested in something that took 41 milliseconds and we want to know what's going on in there, we have the tags, the process, and all the information here. And we can have also context information that we can inject in the trace every time. Thanks.
Oh, hello, hello, hello. Good morning. Okay, fascinating talk. Thank you very much. Oh, I think we have enough time for some quick questions. A couple of quick questions. Raise your hand if you'd like to ask a question. Marc-Andre, and then I'll come over to you.
Hi, very interesting talk. Thank you.
Thanks.
So I have a question about the interface that you had shown in your...
Sorry, can you speak out loud?
Oh, yeah, sorry. Can you hear me now?
Yeah.
Yes. So you had shown an example where you basically just imported something from OpenTelemetry, a tracer.
Yeah.
And then for some reason, things ended up in the Jaeger kind of interface and not in OpenTelemetry. Or is Jaeger part of this OpenTelemetry stack?
Okay, Jaeger is basically oh, can I have the slides? Oh, you mean here? Okay, here we are not sending anything to anyone. Jaeger was when I run the collector using the Docker Compose service. Here, as I show you on the terminal, there was this JSON format that comes out, that is the OTLP format, that we can use that then to send to Jaeger database. And Jaeger database build the trace that you can query through a web interface. The Jaeger that you saw is basically because the gRPC protocol of OpenTelemetry pulls the information from the collector and send it automatically to Jaeger. And Jaeger is connected all together with the receiver, processor, and then the exporter that Jaeger is receiving the OTLP data that comes from the processor itself. Have I been clear enough? Okay.
Okay, I think we've got enough time for one very, very quick question.
Hey, good work.
Hi.
So I just had a question. If we start logging everything and keeping a metric of everything, won't that impact the performance of the application itself in which we are keeping the log? For example, let's say I just add your roll dice example, right? if we start implementing logging of everything and with sampling it's acquired, right? We start logging. Won't it affect the performance of the application to somewhat?
So you mean, what's the trade-off of logging everything rather than sampling, or can you?
It's a simple question. What is the trade-off of logging and tracing?
Well, this is the very long, very. I can.
Please have it close to your mouth.
Hey, is this better? So,
Can you?
is this better?
Oh, yeah.
So, what is the trade-off of logging and tracing and everything that we
Okay.
are doing over here?
Okay. So imagine you have a monolith application that is basically you call a service, you call a request, and then you have a log tracked on your log system. You can go in the log and see what's happening. Okay. You can use log in your monolith application, and then you can understand something if something is erroring somewhere. But imagine that you are in a cloud infrastructure and you have tons of services, and you are collecting logs from 10 different systems that are not talking together. So you're collecting log here and here, but how can you put the logs together? So the trade-off is it's not actually a trade-off, it's just a kind of decision, a matter of decision that you have to take. So if you want to be sure that you can follow the path of your request, you can collect logs just for be sure that everything is collecting something in your system, but then to analyze them and understand if the logs the system are talking to each other, and if something happened, you have to spot the traces. Otherwise, you're going to be manually reading the logs, collecting all the logs, tons of data, giga of text information that are not human readable, in my opinion.
Okay. Hello. Thank you very much. A big hand for Ernesto, please.
Thanks.
Kudos for the live demo. That takes bravery, ladies and gentlemen.